Assalamu alaikum kids. So this right here is October November 2014. Including this तकरीबन हम लोगों ने 9 साल के पास पेपर so 18 papers we've done. तकरीबन सबके मई जून जो है वो uploaded हैं. I just need to stitch together some videos for the October November तो इंशाल्लाह वो जो हैं वो भी एक आध दिन में I'll stitch them together and I'll upload them as well. For now, let's move on towards this paper. Student uses small plotting compass to investigate the magnetic field due to bar magnets. Student places blah blah blah. Okay, so yeah, so we've done this question quite a lot of times. Describe how the student can use the small plotting compass to plot the shape of the magnetic field. So fairly simple answer. So again, essentially you're going to mark a dot, place a compass in front of it, जहाँ पे wherever it's pointing the north, you draw another, you put another, you move the compass to that position, draw another, move the compass to next position, draw another, move compass to next position, draw another, move compass to next position, so on and so forth. And that's essentially how you can draw the magnetic field of this bar magnet on this thin card. All right, so yeah, let's begin. Yeah, so मेरे ख्याल में it's not going to be curve. It's pretty much going to be a straight line. क्योंकि it's going to be, yeah, it's sort of going to be a straight line. But the farther you go, the more magnetic field lines are going to go away from each other. But खैर, 4 points हैं. It's 4 marks, so we need to give 4 points. ठीक है. So let's begin by saying draw a dot or mark a dot as a beginning point. ठीक है. Um, place the compass. Place the compass on the dot. Mark a dot where compass faces north. Place the compass on the new dot and repeat. So you're going to have many dots now. Connect all the points. Choose different starting points. Starting points. For multiple field lines. All right. Explain why plotting compass must be small. Several reasons. One thing that comes to mind right away, more dots, better field drawn. So if you have a large compass, your number of points is going to be very small, so you won't be able to draw an accurate magnetic field line. So when you've got a smaller compass, you'll have more dots, and you will be able to better draw the magnetic field line. Apart from shape, what else can be deduced from the magnetic field with this apparatus? The direction. Again, we've done this question before as well. Or the magnetic field strength. Field strength. Magnetic field strength will of course be given by the space between the magnetic field lines. Question number 2 says blah blah blah. Student raises the load at a slow constant speed by pulling on the Newton meter. Explain why the student uses a constant speed. constant speed होगी means the force will only be used to lift and not accelerate the load. So constant speed means force is only used to lift and not accelerate the load. All right. If you have increasing speed, then some of your force is accelerating the load. So that wouldn't give you a correct value. Suggest a reason for slow constant speed. So you would need a slow constant speed to pinpoint slash measure force. All right. So it's going to be easier to pinpoint the force, right? If the if it's a faster constant speed, so of course it's not going to be easier to pinpoint the force. Or in other words, we can say that it's going to be easier to read the क्या कहते हैं, because जाहिर सी बात है, there is only a certain amount that you can lift the load, right? You don't have an infinite space. So if you lift it very fast, you won't get enough time to look at the Newton meter and make the reading. So we can also say okay, gives enough time to read the meter. Same. So that can be an answer as well. So gives enough time to read the meter. All right. Student measures F for a load W of 0.2 newtons. Figure 2.2 shows the Newton meter when the load is raised at a slow steady speed. State force F. So 10 divisions is 1 newton. So this right here is slightly before the 5th division. So I'm gonna go with 0.45 newtons. So यहाँ पे 0.45 newtons आ जाएगा. Usually that's the case. Mark the position of eye of the student when taking this reading. So it's going to be directly above this point right here. We'll just say that the eye is going to be like so, directly or perpendicularly above. Okay. Right here value, we did that. Plot a graph of F on the y-axis and W on the x-axis. So F on the y-axis, W on the x-axis. Let's do that. Nice that we have an almost square. ठीक है जी. So on acha, so what does it tell me about the axes? Start your axes from the origin, line of best fit. Line a curve hai? Straight line of best fit. Cool. Zabardast. That makes my job a lot more easier. I hate curves. 0.2 and 0.45. So no, first we need to figure out the scale. So weight goes all the way till 1.4. So you've got 1, 2, 3, 4, 5, 6, and 7. Yeah, so 0.2 should give me an exact reading on x. So 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, and 1.4. Right? And on the y-axis, I need to go all the way till 1.2. So how many divisions I have? 1, 2, 3, 4, 5, and 6. So again, 0 to 1.2 divided by 7. Of course, that's not going to give you an exact value. So divide by 6, that gives me 0.2. So I'm going to keep that as my scale. 0.2, 0.4, 0.6, 1.0.8. 1.0 and 1.2. So as long as my scale gives me or uses more than half of the graph or more than half of the divisions given, I'm good. So definitely my current scale is using more than half. So we are good. All right, let's start plotting the points. 0.2 and 0.45, so it's gonna be 0.2, 0.45, 0.4.6. So these are easy values to plot. 0.6 and 0.7, very nice. 0.8 and 0.85 is going to be over here. No, that's going to be 0.9, my bad. 0.8 and 0.5 is going to be over here. 0.85, that's cool. 0.45. Acha, this is wrong as well. So this is 0.5. 0.45 is going to be over here. My bad. 0.6, 0.4 and 0.6, 0.6 and 0.7. So 0.7 was just fine. Cool. Then you've got a 1.0 on the x-axis and 0.9 is going to be over here, 0.95 over here, and then 1.2 and 1.05. So 1.05 is going to be over here, and then 1.4, 1.2 is going to be over here. And we need to draw a line of best fit, so let's do our best. Okay, some more points above the line. Okay, so you still have a lot of points above the line. Interesting. What if bring this up here, make this go down here. So now I have 1, 2, 3 below the line. Okay, so 1, 2, 3 on the line, 1 below, 1 up, 2 up, and 2 below. Yeah, so this one seems fairly better. This point is above, this point is above, this point is below, and this point is below as well. So this right here is a point, or this right here is a line of best fit that I will agree with. Okay? Seems good. Let's move on to the next question. Draw a line of a user graph to find the value of f when w is equals to 0. Okay, so w is 0. W. Okay, I haven't labeled my axis, and I believe कि मैं बहुत सारी videos के अंदर axes label करना जो है मैं भूल गया हूँ. Okay, very important. Please remember to label your axes. So this y right here is force in newtons, and this x right here is weight in newtons. Okay. So this right here would be 0.3, and if I'm not wrong, this right here would turn out to be 0.34. So the force at 0 load is going to be 0.34 newtons. Alright, suggest a reason why the line of best fit does not pass through the origin. So we have these. So that's fairly obvious. It's also pulling up the pulleys as well. Now the pulleys also have weight. So hence, of course, because it needs to force the pulleys up as well. So it's not only the load. जो हम लोड की रीडिंग ले रहे हैं वो सिर्फ लोड नहीं है. That's load plus the pulley that you are pulling up. Hence, force required to pull the pulley. All right. Hence, it's not going to pass through the origin. Gradient निकालना है. So gradient निकालने के लिए we are going to go for exact points. So one exact point we can get over here. That is going to be 0.1 on the x-axis and 0.4 on the y-axis. And then we can go with a point right here. And that point is 1.8. 1.08 on the x-axis, and of course it's going to be 1.0 on the y-axis. Okay, so 1.08 and 1.0. Then we've got 0.1 and 0.4. So gradient is going to be 1.0 minus 0.4 divided by 1.08 minus 0.1. So that's going to be 0.6 divided by 0.98. So I'm guessing the answer is going to be somewhere in the vicinity of 0.64, 0.63-ish. All right. Let's use a calculator. So 0.6 divided by 0.98. 0.612 actually. So a little, I overshot the value a little bit. So it's going to be 0.612. तो आपके सारी वैल्यूज़ यहाँ पे जो है वो 2 या 3 SF के ऊपर हैं. तो आप आंसर 2 SF पे दें या 3 SF पे दें. I'm guessing you should be able to do just fine. वैसे generally अगर question कुछ कहता नहीं है तो 2 SF works. So I'm just gonna go with 0.61. ठीक है जी. Moving on to the next, student is given two resistors 24 kilo ohms. State the colors. पहला जो है वो 2 होना चाहिए red, second जो है वो 4 होना चाहिए yellow, but then there are 0 zeros in front of that, so black. ठीक है. Of course you are going to write the whole thing. I'm lazy, so I'm just gonna write the first letters, but खैर मैंने complete कर दिया. 24 kilo ohms is going to be red and yellow, but then there's going to be 3 zeros, so there's going to be orange over here. All right, तो ये चीज़ जो है वो सबको याद रखना है. So red for the first band, yellow for the second band for both the resistors, and then black for the first one because there are no zeros, and orange for the second one because there are 3 zeros. So 3 is given by orange. Describe in words how the 3 resistors are combined to give the smallest possible resistance, all connected in parallel. When all are connected in parallel, you'll get the least resistance. Okay. 3 boxes, draw 3 other possible combinations. So all 3 are in series, so we can go with 1 in series, the other 2 in parallel, like so. Yeah, इसको जो है, let's go with this rather. ठीक है, you can have 2 in series, like so, and 1 in parallel with the 2 in series. ठीक है, or you can have all 3 in parallel. All right. So there's that. Student needs a resistance of 36. 36 kiska hoga. So each resistor was 24 if I'm not wrong. 3 identical 24 ohm. So yeah, this is going to be 24 plus 12. So this is going to be 36 ohms. So ये आपका E हो जाएगा. This right here is going to be E. Next question. Student is given a cylindrical beaker. He is asked to find the outside diameter or the other apparatus available is shown below. So you've got a list in your account. You should describe in detail accurate value for the outside diameter. Okay. So 2 half-meter rules, 30 centimeter, 2 meter thin string, 2 meter thick string, plain paper, blocks of wood, marker, pen, pencil, scissors, blue tack, sellotape, lined paper. Interesting. So the two things that come to my head right away are to place the beaker in between the blocks of wood and then measure the distance in between the blocks of wood. And repeat that, rotate it and repeat that several times ताकि if there is any inaccuracy in the shape, that will be accounted for. The other thing would be that you can use any one of the strings. Of course, I would go with the thin one, and you wrap it around 10 times the beaker. So yeah, so once you wrap it around 10 times the beaker, you then measure the length of the string. Okay, you've got 2 half-meter rules, so you should have you should be able to measure the length. All right, or maybe only make enough loops so that you can accurately measure up to 50 centimeters. क्योंकि 2 half-meter rules हैं तो accurately 50 meters तक होगा, because usually rulers have dead space in between. And then you can mark and figure out as well. But I guess the better way would be the way of the blocks of wood, because then you won't have to measure excess length, right? But I guess both of these would work just fine. So दोनों cases में हम लिख लेते हैं कि क्या क्या चाहिए होगा. In your account you should state the equipment. So blocks of wood, and a meter rule, a half-meter rule. Just one would half-meter rule. Just one would do just fine. Take care. Explain how the equipment is used. Place beaker. Place beaker in between blocks. All right. Mark the position of the blocks. All right, so we've marked the position of the blocks. Measure distance between the blocks. All right, explain how the value of the diameter is obtained. So you just measure the distance between the rod blocks. This is the diameter. This is the diameter. State how would you make the measurement more accurate? Rotate the beaker. Rotate the beaker and repeat several times. Several times. All right, but I guess this would not give you all 5 points because we have 4. So here you should go with the string theory. All right, not the string theory of the theory of everything. The string theory, by that I mean that you should take the string, wrap it around the beaker several times, then measure the length of the string, and then divide that by n, the number of times you looped it around the beaker, and then pi into d for the circumference. You can get the diameter like so. So in that case, we will need a 2 meter thin string. And 2 half-meter rules. 2 half-meter rules. ठीक है. You need a marker pen as well. Marker pen as well. So you need a marker pen as well. marker, pen. ठीक है, explain how the equipment is used. So wind the string around the beaker, n times. Let's put this n times, or you can write a value 5 times or 10 times, whatever. Mark the point where it completes nth rotation, nth rotation. ठीक है जी. So where it completes the nth rotation, explain how the equipment is used. Within that, state any readings taken. So unwind the string. So point number 1, point number 2, point number 3. Unwind the string and measure the length L of the string. ठीक है जी. So we are going to say, then we are going to say how to find the diameter. The pi into d would be equals to L upon n. So the total length of the string divided by n, the number of rotations. That's going to give you the total length of going one time around the beaker. And then you can use it equal to pi d. And repeat. You can say, to make it more accurate, you can say that repeat at various points or various heights and average various heights and average. ठीक है जी. So I'm guessing this right here gives you more material to write. तो इस वजह से आप इसी के साथ जाएंगे. ठीक है. So that's one reason why it is more difficult to measure the internal diameter. You cannot put wooden blocks. You cannot use a string inside. तो ऐसी बात है, it becomes quite awkward. इस वजह से probably आप जो है वो use नहीं करेंगे. So yeah, because हम लोगों ने strings use किया है, तो we are just going to say cannot use string inside the beaker. ठीक है. And that's it for this paper. All right. So yeah, same thing. I'm going to repeat the same message, bachas. कोई भी questions हो, post them in the comment section. And if you have any issues, let me know. Like I said, I probably missed out labeling the axes in the previous videos. I should not have forgotten that, but I did. ठीक है. तो आप जो है वो प्लीज़ रिमेंबर टू लेबल. उसका कम 1 मार्क तो होता ही है हमेशा. ठीक है, तो उसको लेबल ज़रूर कर लीजिएगा. I'm gonna add that in the comment section of every video as well, so that everyone gets that message of mine. So yeah, that's pretty much it for today. Inshallah, kids, I'll see you in the next one. Bars out.